Hi guys, we're gonna talk about area of triangles. I'm gonna explain to you 3 exercises I thought it might get complicated to use somehow. And the whole point is when you work with a lesson, just work on those 3 and then check with the answers I'm giving you here in the video, okay? So let's begin with problem number 9, which is an irregular shape compound by 1 parallelogram and 1 rectangle. As we were working with perimeter earlier in lesson I believe 20.1, right? Now we can end 20.3. Now we can actually do the same with areas. What are we gonna do? We're gonna determine that the total area gotta be the addition of the 2 areas, area 1 and area 2. And then I gotta define what are the measures for each. So the first area, of course, is going to be base times height, which is gonna be 30 times 9, and we know that is 270 square feet. Please do not forget the units. And then we're gonna do area number 2, which also is base times height, and here is gonna be 30 again, times 11. How do I know it's 30? Well, this side is 30, this side gotta be 30, and of course this side gotta be 30. So they all are 30, that's why I know. And I'm gonna get 350, in 30 square feet. So then the total area gotta be what? Well, just the addition of the 2 areas I found, which is gonna be actually 600 square feet, right? That's it. Now let's work on problem number 10, which is a very similar figure. And I'm pretty sure you guys can do it on your own. Pause the video and then check on your answers, okay? Again, we're gonna have 2 areas, but this time both areas are actually gonna be parallelograms. So we have to add those, of course, because we don't have any holes. When we have holes, then we would have to subtract. But right now, we only have to add. And then the first area, base times height, gotta be 24 times 9, which I know it's 36, and then 18, 216 square meters. Then the second area, also base times height, it's gonna be the same 24 times 8. Now please notice the 15 and the 10 are useless right now. They're not gonna help us find the area just because they're actually the lengths of these sides, and we don't need those sides to get the areas, okay? Now 24 times 8 is gonna be 32, and then 16 plus 3 is 192 square meters. And the total area again, it's to add these 2 areas we found. So that's 390, 408 square meters. See, that easy. So these 2 problems, I don't think you found them any complicated at all. Let's go with problems, or I'm just gonna talk about 1 problem, but you actually need to work on the whole group to be able to work on problem 15. Now, problem 15, 14, 15, and 16, I believe, are all related to the same diagram in the book. Number 14 is easy because you have to find and measure yourselves with your ruler in inches, of course, and then you have to figure out what shapes to measure and what areas to find. In this case, you're finding parallelograms, areas of parallelograms. And once you find those areas, then you gotta go and work on number 15. Now, number 15 is actually asking you to convert one measure, that is the model measure, that means the diagram measure, to actually be able to get the actual measure, which is the real measure of the garden you have right there. How do we do that? Well, they give you a scale factor. They give you a scale factor that we need to work with. Now, the scale factor they give you is that 1/4 of an inch is actually 1 yard. This scale factor is for linear measures, but we're talking about area. So what that means is that I need to change this factor to areas. How do I do that? Well, it's just a matter of just getting the square of both, right? Why do I have to get the square? Well, because as you know, area is about square units. So I need to get the square units, and at the same time, the coefficients that are right next to the units are gonna get also operated, okay? So here I'm gonna have 1/16, that's gonna be the square, okay? Square inches, and then here I'm gonna have 1 square yards. Now you might think, well, why do I get 1/16? Well, think about 1 square, which is 1, and 4 square is 16, 4 times 4. And then 1 square is 1 as well. So this is the scale factor we're gonna work with. Now, since you have to measure in number 14, in problem number 14, I'm gonna make up the measures for one parallelogram so you know how to work on that problem. I'm gonna work with the bigger parallelogram, okay? That's probably gonna be number 1, and that's gonna be the bigger one of the two. And then I can just say that the width, it's gonna be, let's say 1/2 of an inch. And then the length, it's gonna be 1 inch long, okay? So the area, of course, which we know it's based on height, well, it's gonna be just 1/2 square inch, right? So that's what we're gonna work with. Now, how are we gonna work with these two things? We're gonna work with these two things just as we did with circle graphs. Remember the relationship we had to create to get the angles measures when we had the percentage in the circle graph is the same thing. So think about this. 1/16 square inch is actually equivalent to 1 square yard, right? In real life. Because remember, this is the measure for the diagram you have in the book. This is gonna be the actual measure in real life of that garden. So what I have is actually the area of the diagram in the book. So I'm gonna put it up here. 1/2 square inch, okay? And of course, what I need to find is the measure of that patio in real life. And again, we're gonna do the same we used to do with the circle graphs. That means we're gonna do cross product like this, okay? And so if you think about it, we're gonna have 1/16 inches square of x. It's gonna be 1/2 inch square times 1 yard square, okay? And so here I'm gonna have 1/2 square inch times yards inch. I'm not writing down the 1, well, because it's a little bit pointless to write it down. And then I'm gonna make 1/16 divide down here, okay? How is that gonna work? Well, I don't have any more room, so hopefully you took notes. I'm going to erase here, and I'm gonna continue. So if you notice, I can actually cancel the inches, right? And if you notice, I can also divide fractions. So what that makes me is to get outers and inners, right? And so that's going to be x equal to 16 over 2 square yards. And that is going to end up in 8 square yards for the first parallelogram. Now you would do the same with the second parallelogram, which is the smaller one. And then you would have to add the areas, right? Please keep this in mind to do problem 15, okay? This is just an example. Remember, you have to do your own measurements on number 14 to be able to do number 15. But I wanted to show you how to do the conversion, just in case you don't remember how to do conversions. First of all, back in December we did that. And second, how to figure it out, because it might not be as clear even though we just did it with circle graphs. Okay? All right, then I'll see you later.